In a previous lesson, I talked about graphing practical problems that were set up as equations. Because they were equations, there were several different sets of answers that were all found on the line that was graphed. This video talks about graphing inequalities. An inequality is a statement that says that one value is greater than or less than another value, but it is not necessarily equal to it. When graphing an inequality, we get a whole area of points, not just points on a line. Because of that, there are all sorts of possible answers to the question, and oftentimes an infinite number of answers. To start off, let's look at a problem similar to the one in the last section and expand from there. Tom sells hot dogs and pop at a stand. Hot dogs sell for $2 each, and pop sells for $1 each. His expenses for the stand are $30. What are the possible combinations of hot dogs and pop he can sell to break even? In order to go through and solve this, I could say that X is the number of hot dogs and Y is the number of pops that he would sell. And then you can see that this would be a possible equation. 2x plus y is equal to 30. And since it's written in standard form, I could go through and set x equal to 0 and solve, and then set y equal to 0 and solve. So I'm going to set up a t-chart, and if I do let x equal to 0, that means that y would be equal to 30. If I let y equal to 0, that means x would be equal to 15. And you can see that I have gone through and I have plotted those two particular points, 0, 30, and 15, 0. I, of course, could also find some other points if I wanted to. For instance, the point 10, 10 would work, and I have plotted that, as well as the point 5, 20. That would also work. There's actually a number of different points that would work on here, but I could go through and I could solve this that particular way and find some combinations that he could sell to break even. So, anything on the line means that he breaks even. However, since the reason for being in business is to make a profit, doesn't he want to sell more? That would mean that any combination of points to the right of the line would be a profit, and any combination of points to the left of the line would be a loss. In other words, if I change this to, instead of saying what are the possible combinations of hot dogs and pop he can sell to break even, and instead say what are the possible combinations of hot dogs and pop he can sell to make a profit, then I really am asking a different question. And I would really have now an inequality. Now I still have 2x plus y, but instead of equal to 30, I want to know the possible combinations so that he makes more than $30. So any point that is on this side of the line means he's going to make a profit. Any point that's on this side of the line means he's going to be operating at a loss. And once again, any point that's on the line means that he is going to break even. This is really what the idea is behind inequality graphing. Many problems in business have more than one set of factors controlling the decisions. For that reason, inequality graphing is generally more than one line on a graph. There may be 2, 3, 4, or even more lines that need to be drawn in order to determine a possible set of answers. Here's an example of one of those types of problems. Jill has no more than $36 to spend on fruit for a party. Apples cost $3 per pound and peaches cost $2 per pound. She needs to buy at least 10 pounds of fruit. How many pounds of each type of fruit can she buy? In this particular problem, because there are two different demands on Jill, she can't spend any more than $36, but she also needs to buy at least 10 pounds of fruit. We need to come up with two different equations based on that information, graph both of them on the same graph, and then use the information to determine possible answers that will meet both demands. So you can see that what I've done is I've said, well, let's let X equal the number of pounds of apples, and let's let Y equal the number of pounds of peaches. One of the equations, it says she can spend no more than $36. And apples, which is my X, the number of pounds of apples, cost $3 per pound, and peaches, which is my Y, cost $2 per pound. So one inequality that I could write is that 3 times the number of pounds of apples plus 2 times the number of pounds of peaches has to be less than or equal to 36, because it says she can spend no more than $36, but she can certainly spend $36. For the other inequality, it says that she needs to buy at least 10 pounds of fruit. So that would mean that if X is the number of pounds of apples and Y is the number of pounds of peaches, my inequality, adding up X plus Y, has to be greater than or equal to 10, because once again, she can buy exactly 10 pounds of fruit. Once I come up with the two different inequalities, then I am just going to go through and I'm going to set up T-charts. And when I set up the T-charts for both of these, I am just going to pretend that they are 3x plus 2y is equal to 36, and to find points that would be on the line, and the same thing, x plus y is equal to 10. So I can just find the points on the line, so I can graph that line. When I do this first one, 3x plus 2y is equal to 36. If x is equal to 0, that would mean y would be equal to 18. And if y is equal to 0, that means x would be equal to 12. So I want to graph a line that uses those 2 points. Then for my other one, once again, if x is equal to 0, y is equal to 10. If y is equal to 0, x is equal to 10. And I want to go through and I want to graph another line using those points, so that then I can start to make my determination of what combinations will work for both of these. I've already gone through and graphed this, but I do want to go through the steps of what I did just so you can see. First of all, notice that when I went through and did this, that I went through and I came up with my labels for my X and my Y, which are the same things that we had said that they were before. And I also decided to use the scale counting by 2s on both of those different axes. Then what I did is I graphed this line first. 3x plus 2y is less than or equal to 36. And I put in the points 0, 18 and 12, 0. And I drew a line between those because that is the equal line for that particular just equation, not inequality. Then I did exactly the same thing for the x plus y equals 10 line, and I put a dot at 0, 10. I also put a dot at 10, 0, and I connected those 2 points. Well, anything that's under the top line means that the cost would be less than $36. So I know anything to this side is going to be less than $36 because the line itself is the $36 line. And then at the same time, anything that's over the bottom line means that I would be getting a total of more than 10 pounds of fruit. So I can pick any point in between these two lines, which is the area that I shaded in. Now, I gave you 2 different points in there that I know would work, that I could give you the possible combinations. One of those points is the point 4, 10, which is this point right here. And another one is the point 6, 8, this point right here. So those would be 2 different possible combinations that she can buy that would satisfy both of the demands that she has on her. She can't spend any more than $36, and she has to buy at least 10 pounds of fruit. In this first video on graphing inequalities, I have tried to explain the difference between graphing inequalities and graphing equations. Remember, there is not really a big difference. When graphing inequalities, I am still graphing a line, as if it were just an equation. However, when I get done, I am choosing points on one side of the line or the other, depending on the parameters of the problem. In the next video, I will do a few more examples.